All right. Hello. Hello, hello. Welcome to the stream. Gotta move some stuff around here. But yeah, hey, welcome to the stream. Solar Loon here. I'm an independent game developer. I'm the creator of Master Plan and Tetra 3D and a whole bunch of other stuff. And yeah, I thought it would be good to do some game development on this thing I've been working on for the past couple of months, past maybe 6 months or so. And it's going pretty well. So I just wanted to kind of show it off. Well, not show it off, but work on it a little bit. I don't have a lot of time today, so well, actually, I might. Well, anyway, I don't have a lot of time today, so maybe we'll see what we can do. We'll see how much we get done. But yeah, let's get started with some music. We'll get some music going. Let's listen to something a little different. Hold up. Where's... There we go. Cool. Hold up. Let me just do something real quick. Okay. Alrighty, so last time we left off, we were working on this. Oh, that's right. That's right. Last time we left off, we were working on this, which is, well, this is the game. How do I have to start it? There we go. So this is the game, re-implementing it essentially from scratch in WASM. Well, it's not wholly re-implemented from scratch in WASM, but basically by implementing it with WASM, which is WebAssembly, the goal is to basically make it super easy to mod this game while also maintaining the what's the word? The performance, the you know, make it run well while still also making it you know, look good. So yeah, it's going pretty well. Not going too shabbily. New API, new stuff. Update is pretty small. I'd like to keep it lower, so we'll see. I'll see what I can do to kind of keep it keep the performance down. But overall, this is looking pretty good and shaping up. And I'm porting more and more bits of the code over from the original version of the game to this version. So it's working pretty well. Looks pretty good. I think there might be a memory leak or something, because I feel like I saw the frame rate jump to like I thought I saw the frame rate jump to like I'm just looking at the FPS like, why is it so high? like I get it, but I don't get it. Anyway, it's the refresh rate, and yeah, anyway. But yeah, this is running well. This is running well. I think that there might be a memory leak or something, because I remember running the game and leaving it running and coming back maybe a couple hours later, and update and draw were both high. Draw was maybe 8 milliseconds, but there might have been something else running on my computer that was slowing things down too. So I have to kind of do some testing to see if I can get to the bottom of it. And that FPS value isn't true FPS. The game is only updating 60 FPS, so it's not drawing differently, so to speak. The game isn't running at 180 FPS. It's a 60 FPS game, but the drawing happens 180 times. But the frames where it's not changed, nothing draws. Like, it basically skips the frame, I think. I believe that's how Ebi Tension works. But anyway, this is shaping up. So we have light volumes, that's been implemented. We have animations, that's been implemented. So I've been basically working on implementing these things under this new API, where basically it's kind of like a lot of it is in implemented in WASM itself. So like nodes are here. I mentioned this on the last stream, but basically the nodes are just identification numbers, and cloning them or whatever, that is handled thusly, where basically we're just sending the number and a function to a host side function, host side defined function. So basically we're not like storing all of the data for a node in WASM, we're just storing the identifying number. So this works well. This is fine. Yeah, this seems to work. So there's a couple things we want to do. One is we want to fix this jumping because it's not like on time. Let's see what we can do about that. Okay, so that's interesting. So on ground. Oh, I see. That's why. And I'm not sure if I like this approach, where basically instead of having a nil pointer, I'm just using a struct that has a plain number. I'm not sure how I feel about this, because they're effectively the same, but I feel like I would prefer to be able to use nil to point to in a lack of existence of a node, as opposed to something like this where like this is okay, but it just, I don't know. Oh, that's what I was gonna do. I need to implement mouse cursor locking, so we're gonna implement that. Also, this is like a cool little visual, like slightly 3D. Okay, so let's do a couple things here. Mouse. We probably want the mouse. We might want some sort of strength. Oh, I didn't. I'm not. There we go. Cool, that's better. Okay. Yeah, let me change something real quick. There we go. All right, so cool. All right. Okay, so mouse, or input rather. Mouse. Mouse start. Let's see. So visible, and let's see, what are our options? Visible, hidden, and captured. Okay. Okay, something like that. Really, this is just mouse lock. Okay. That's what we're looking for. Cool. Okay. Let's see. Mouse cursor mode. Cursor mode. Set cursor mode. Okay. So that should work. So now we can go back over to game. Let's reload this. All right. Cool. Now we should be able to say, oh, we want this movement mode to be or set, yeah, cursor mode, engine, mouse, lock, let's say hidden. But actually, let's go back because it should be, these should be mouse cursor mode. Input, oh, mouse set cursor mode. Cool, so now the mouse cursor is, it works, it's just hidden. Or we can say we want it to be captured. So now it can't escape. Cool. Okay. Very good, very good. So what I wanted to do next, let's get the these chips animating. Oh, I see. It has a base. Yeah, base. That's right. Cool. cool. Okay, so now they're bobbing up and down. But it takes a surprising amount of time. Went from 0.4 to 0.8 milliseconds. 0.5. Oh, this is... Gotta ban this spam bot. Monochroma 360 says, "Hi, the game is looking great. Love the collectibles." Yo, thank you. Still have to actually animate them. Right now I'm just looking at the update time. It's like what I'm doing is just calling a function to get the local position of an object in the game space 10 times per chip per each of these little collectibles. And doing that just for these 10 times is eating up like 2 milliseconds almost. Maybe 1.5. So I'm wondering if, like, I understand why, but I'm wondering if there's a better way to do this stuff. Maybe if I reused. Let's try something real quick. Okay, so we're sitting at 2.2 milliseconds or so, 2.2, 2.1 in that range. With this, we're sitting at about the same. So what that tells me is the time taken is probably not on Go side. It's probably rather on the side of, yeah, it's like maybe 0.1 milliseconds. It's not enough to really worry about. Like from 2.1 to 2.0, maybe 2.2 to 2.1. But this is taking a lot of time, so I think it's probably... Well, let's do some profiling. That's interesting. On my... Whoops. On, like, on OBS, I'm seeing flickering, but not on my screen. Like, I don't see flickering on the screen itself, which is interesting. So we'll just put that over there. Let's do this like this. I think I might have to go, unfortunately. I have to get to the airport, but gotta get to the airport. But I can definitely pick this up later on today. It's just I might have to go right now. But we'll see. We'll see. Let me look something up real quick. Okay, so then yeah, I'm actually I believe I have as much time as I thought I did, so never mind. I still might pick up this stream later on because I'm gonna have to end it at like maybe 1:20. But anyway, so what I'm thinking here, let's see how much time it takes just to call this function. So we're losing 1 picosecond or microsecond. 1 microsecond just to call the function. So it's not, the function itself is not the problem. This includes calling the function that interacts with the host process, as well as the processing of that host process. So I could do this 1,000 times and it would take 1 millisecond. So that's not too much of a problem. So then is it the reading of the buffer that's really problematic? Yeah, that's like 5 times as much time, or I guess 4 times as much time. So this is just call host, and this is reading buffer. Okay, yeah, so calling the host is 2 microseconds, reading the buffer is 10, calling the host is 1.5, reading the buffer is 11. So we want to do something about 26. Yeah. So if we did this 100 times, we would be eating up 2.6 milliseconds. So we want to trim this down if possible. So I'm thinking, because the way this works, we are basically calling out to a host function, allocating memory, putting data in that memory, going back to WASM, reading the data from that memory, and then making it into a vector 3 in this example. So this process, we want this to be faster. Reusing the buffer didn't make much of a difference. Slicing shouldn't be a problem. We're reusing both the byte buffer to load the memory, copies the host memory block to the provided buffer byte slice. Do I have to load it, or can I like... Read bytes makes a slice. Offset length. Free store load. We can load memory. Well, I feel like we do want to load the memory into the buffer. It'd be nice if I could read the memory without having to load it, though. but maybe that's not possible. I wonder if it would be faster to like write all, like allocate one big block of memory and then manually write and read to that block. Because then if I do that, no, because I would still have to call the internal functions to write to the memory. Oh, my water's not here. Let's see. Well, rather than this, we could actually do this like... Excuse me. Does this grow the capacity or the length? Capacity. Reading buffer. Let's feel like that's about the same. Mem.load bytes buffer. Like if I could return multiple floats manually, that would work. But since I can't, maybe I can like return, like turn an uint64, because a float, like if I'm writing a float 32 only requires 4 bytes, so it can be encoded in a larger number. Then I don't have to allocate memory, really. Interesting. That's a very interesting concept. Okay. So I can use a single number to represent up to 4, 8, 12, 16... Wait. A byte is a uint64 64 bits. 64 bits. So that's 8 bytes. Okay. So I could represent a 8 value vector using a single up to an 8 value vector using a single uint64 with 32 bits of precision, or I could do like a float 16 encoded into a uint64 for even more. That might work for matrices. Okay, so here's the concept, because we want to avoid, I think we want to avoid, and we can copy this over here because it's, I think, slightly better. I think we want to avoid allocating memory if we can help it. Yeah, so let's try this. What we're gonna do, we're gonna go to here, local position. Okay, it's this guy. So we're gonna make out vec3 uint64. So ultimately, we'll do like this. UNC4 representation of B is 0 to 8. Okay. So the concept is we want to use the number directly. We want to return a number that can represent the x, y, and z values of a vector. Something like this. You can write bytes, ints to bytes. We're writing that to a byte slice. Yeah, okay. So I don't want to convert numbers to bytes. I want to convert numbers to one number. I want to encode the number. So I guess I want to convert a single number to bytes, to a byte slice. Because we want to avoid having to encode and decode to and from memory. I think that's what we want to avoid doing. Something like this. Because, am I wrong? Well, a float 32, only 2 float 32s could fit into a UN64. Can I fit 4? I would lose precision. What if I don't care about losing precision? What if I wanted like a float 8? That's still a lot of precision. That's 4 on the left hand, 4 on the right hand, right? That's a lot of precision. Float 8. This is what I was looking for. That's what I'm looking for. And computing mini floats are floating point values represented with very few bits. The library implements float 8-bit uint8. Memory and storage efficiency are crucial, but lossy precision is acceptable. Okay, so this is an idea. So I could work with a float 8 to basically turn vectors, the XYZ and RGBA components of vectors and colors, into basically numbers to transmit without having to allocate memory. This will probably be a lot faster. This would probably be a lot faster. Because I can't really spending 2 milliseconds just on making these things float is crazy. Spending 2 milliseconds just on making these things float. Let me see. I'm just thinking, man. I'm like, do I really want an 8-bit float? Not 16. Like not 64, not 32, not 16. 8-bit float is crazy, but at the same time, I'm like, it's not that much, right? I mean, like that's a lot. That's a lot of data, I think. Okay, so let's see. So this example, I'm not sure if I'm looking at it right. Let's see. Floating point 24, 10-bit, 11-bit. NVIDIA and others announced support for FP8. Convert from FP8 by truncating the trailing digits. So it goes up to 0.11. Examples 8-bit. A mini float in 1 byte, 8 bits with 1 sign bit, 4 exponent bits, or exponent bits, and 3 significand bits. Significant? This is a chart of all possible values for this example 8-bit float. Okay. It goes up to 240. There are only 242 different non-nan values, but this isn't. This is bit 4-bit, 3-bit, 2-bit, 1-bit. Yeah. Wait, yeah. 8-bit float. Floating point, a mini float. Very little dynamic range. Micro scaling formats. What about fixed point arithmetic? (16-bit sign). Let's see. So that's the range of values. Okay. Interesting. This is very interesting. What about float 16? Maybe float 16s would work. If I could store 4 of them. I could store 4 of them. If that works. If that's how that works. I don't know if it... Well, I guess, yes, I could store 4 of them in a float 64. So at the very least, I could work with float 16s. That's an idea. Because you don't really need a 32-bit or even 64-bit floats for most things. All right, let's test this out. Let's just test something out. Local position. So we're gonna try this. Let's just try this. We're just gonna do that. Well, we still have to pretend like, I mean, we still have to. Well, how would I even? How can I write bits to an UN64? Maybe I can add them together. No, I can add them together, I don't think. Like, how do I convert a value into a UN64? Interesting. Okay, so looking at this, a float 16 is a UN16 to begin with. Let's see. New float 16 from bits. Interesting. Okay. So UN 16. Okay, can I turn UN 16 into UN 64? I see. Okay. Okay. All right. So let's give this a shot. Let's give this a shot. Just look through it real quick. Kind of get an idea of what it's doing. Anything unusual? I don't see anything unusual. Okay. All right, so the idea here is pretty simple. Let's see, how do I actually make a float 16? Oh, it's called float 16. Oh, this isn't even it. Was no float 16. Bruh. Okay, let's see. Bruh, okay. Did I not import this? Let's see. Okay. So this says you can shift the master above UNT 64 left by 16 bits and then something like this. actually, I want it in this original. Or can I just do that? There we go. All right, let's try this. Okay, let's do go again. I'm this is a crazy concept. I'm just, my brain is like buzzing. Let's see. There's just a lot going on. Like mentally, I'm just trying to understand. Like, okay, this. Okay, so now I have to decode it, right? So to load it in in reverse order. Shift inventory space. From bits. From bits. This is a crazy concept. All right, so well, let's just start with this, I guess. Okay, so this is what we're getting. So we're pushing the data over and then This is... I think I have to go, unfortunately. Man, this is interesting. But I think the core concept is I want to try to avoid storing, allocating memory if at all possible, which is possible to do with smaller numbers, with smaller values. If I'm using a float 16 as a representative value, essentially. All right, yeah, I gotta go. But anyway, this was fun. I might pick this up in like a few hours. But yeah, thank you very much for watching. I've been Solar Loon. I'll have to catch you guys on the flip side next time. Sorry we couldn't get a lot done this time, but we're gonna definitely get some progress on this, because there's this could work, and this might minimize the amount of time that it takes to actually run this stuff. It might run a lot faster. All right, well, thanks. I'll catch you guys later. See ya.